Hello, welcome everybody to our robotics class. So I believe this is week 11, I think. So last week we were introduced to our new robotics program that we are using, the VEX Code VR. So I've started going through the curriculum with you guys, and we're starting out pretty slow because I feel like we just need to get comfortable using the program. And also, because the first assignment that I asked you to do was to send me a file here with your code. And this was very important because we are going to be doing different projects in here. And the way that I'm going to be grading you and seeing that you're able to do this is by you sharing the file with me. So I did receive, I would say, let's see, I don't know, I'm looking at it now. I received probably a few from each class. I don't know, not too many, not too many. So I hope that you guys are able to do this. And I'm kind of like a little bit nervous to move on because I feel like we can't move on unless you know how to do the file. So if you did not send me that from the first week, then you have to do that before you move on to the next part of the lesson. And I'm not going to really start with any coding this week because again, I'm not going to start that until you send me the file. So I know that you know how to send the file with the code in it, okay? So we're just gonna go over some of the basic things of using the program this week and some basic concepts that apply to coding and specifically this coding program, right? Coding with the VEX robot. So there's going to be a quiz this week. The quiz is going to be through Google Quiz, and so it will be automatically graded. But my suggestion would be that you take out a piece of paper right now, and as we're going through the lesson, you jot down notes, because you're going to need your notes to be able to complete the quiz. And yes, you can use your notes for the quiz, but again, if you don't take notes, then you're not going to, probably not going to know any of the answers on the quiz. And notes are a good way to help you because then you can go back when we're using the program as the weeks go on, if you need to check on something and see, oh yeah, I forgot what that does, or I forgot how to do that, you can always go back to your notes, okay? So last week we started with just getting started with VEX Code, and we talked about opening an example and running your first project. So we did that, and then we had, everybody was supposed to share their first project, right, by saving the file to your device and then emailing it to me. So let me just show you really quick. When you do it, well, actually, I'm not going to show you again. You guys, you know what? You guys should know how to do this. I spent the whole video last time, so you could go back to the video last time if you forgot how to do it. I'm not going to do it in this video. Let's just move on. So now we're up to block shapes and their meaning. So hopefully, if you were with me in previous years, you remember code.org, you remember Tinker, you remember Scratch. These are all Blockly languages, right? They use blocks. And blocks are good for beginners because it tells you on the block what it's doing, right? And behind every block is a real coding language that we are not going to be using because that is something that you would take in a more advanced course, right? So this is more of like an introductory course with using code. So we use the blocks. And as you can see, the blocks have different colors, right? And they have different names on them. So very similar, different categories. The drivetrain category are blue blocks. They're blue blocks. And so you would know that if you saw a blue block, you know it's going to do something with moving the robot, right? Because it has to do with the movement, the drivetrain, right? So it might be driving it forward, turning it right. There's a bunch of different drive blocks in the blue category, right? So if you click into each of the different colors, you will see that each of them has different blocks, right? That you would use depending on what you wanted your robot to do. Now, the when started block, you do need that all of your blocks need to be connected to a when started block. Otherwise, when you go to run your program, the code will not do anything. So for example, if say you had spent some time connecting code out here, and then you went to run, you press the start button. If it's not connected to the when started block, it's not going to do anything, okay? And the reason being is that the when started block is what tells the program that when you click the start button, do whatever code is attached to it. So if nothing is attached to it, it will do nothing, okay? So hopefully that makes sense for you guys, because you have to remember that you always need to connect code to a when started block. Okay, hopefully that makes sense. Okay, so let's move on. So what else did I want to tell you guys about the blocks? Oh, okay, so if you click on the little question mark and you click on any block, it will tell you how to use the block. So for example, I just clicked on the drive forward. So it says, what does it do? It moves the drivetrain forever forward. How to use it? The drive block will run the drivetrain forever until a new drivetrain block is used or the program is stopped. Choose the direction the drivetrain will move so it can go forward or reverse. So it tells you what the block does. So this is a nice feature. This little question mark is a nice feature because you can click on any block and it will explain to you what the block does. So again, for all of us, this is great because when you're using a new program, you may not know what all the blocks do, and so you can easily use that help menu. This one that says turn to heading 90 degrees, it says it turns a drivetrain to a specific heading using the built-in gyro sensor. So it says the turn to heading block can be used to turn the drivetrain to any given clockwise heading. And so again, you can change it to anywhere from 0 to 359.99 degrees, okay? So, and which would be a full turn around, right? So if you're thinking about turning around in a circle, right? How many degrees? Okay, so hopefully that helps you with the blocks. So again, a lot of different blocks. And the more that you use it, the more you get comfortable knowing what the blocks do. So something else to mention, not only do the blocks have different shapes, but they have a shaped slot for other blocks to be inserted into them. So if two blocks cannot be joined together, you will know because they will not fit together. So if you notice, like this block fits nicely into this block, right? Because it means that they're meant to go together. But there may be some blocks that do not fit nicely. And that means that it's because like this one, I cannot connect this to the when started because this is part of something else that we would use with another block, right? So you need to be careful. And it's nice that they do this because they kind of set you up so that way it makes it a little bit easier for you to know if the block doesn't look like it fits, it's because it's not supposed to, right? Okay, so I think that's all I wanted to mention about blocks. Okay, let's go to tips and tricks. So tips and tricks, the main things I will bring up with you guys when you're working on here, there's these little magnifying glasses. So there's a plus sign that'll make the code get huge, and the minus sign will shrink your code down, and the equal sign will bring it back to its original setting. Okay, so if you're working with your code and you want to make it bigger, you want to make it smaller, you could use the plus sign, the minus sign, and the equal sign brings it back to its normal size. Okay, so hopefully that also helps you. These are just little tips and tricks. A couple of other things. When you go to run your program, it runs inside the playground. So there's your playground. So whenever you run something, it will run in the playground. Okay, so remember there was different types of playgrounds. Oh, excuse me. I think we're going to be using the Castle Crasher for our first one. So this is a playground. This is where your actual robot is. And so when you hit the start button, you're going to see everything happening inside of the playground. All right, so when you're ready to do that, start button is what runs all the code. And then you guys already know about renaming your file. You rename it here when you want to send it to me. you go to file, load from save to your device, and then it'll save in the downloads file, right? So that's all stuff from last week that we already went over. So what we're going to do now is move into the course. So we're going into Unit 2. And this is a little introduction, and then we're going to review some things about computer science. So we're going to be solving a castle crasher challenge. And this is going to help you learn how to move the robot around. And you're going to move it around this castle crasher playground. And you're going to have to learn how to sequence commands correctly to knock over all of the castles in the playground. So let me put on the little video clip, just kind of introducing this unit.
In this unit, you will learn how to use drivetrain commands to drive the VR robot around a playground. A drivetrain is a mechanism made up of motors and wheels that make the VR robot move across a playground. The drivetrain commands are used to move the VR robot forward or reverse. Drivetrain commands can also be used to turn the VR robot left or right. You will also learn how to sequence commands in the correct order to make the VR robot complete behaviors in a certain order. Finally, you will get the chance to apply these skills to solve the Castle Crasher Challenge. In this challenge, the VR robot will knock over every building on the Castle Crasher playground. Have fun learning how to solve the Castle Crasher Challenge.
Okay, so fun. I don't know if we'll actually get to the challenge during this lesson, only because I didn't receive enough of your files from all of you guys, so I really can't move us on to the next thing until I have received your work from the previous week. So that's why it's so important that you do your work every week, right? So remember I was saying set aside 1 day a week for your robotics. I would say, gosh, 30 minutes, 20, 30 minutes, and just make that be your time that you do it. Because we can't keep moving on with these lessons if you're not doing the ones before. It's not like they're all connected to each other is what I'm trying to say. So they build upon each other. So that means that if you didn't do the one from week 1 and then we're on week 5, you can't just do week 5 because you didn't do week 1, right? So they move along and they build upon each other. So please make sure that you're doing the lesson every week. And honestly, like last week's, it shouldn't take you like less than 5 minutes to go in and practice saving the file and then emailing it to me. It's super easy. So please do that right away so that you can move on and we can move on to be able to do some of these fun challenges that they have for you guys. Okay, so let me move on now. So now we're going to talk about a little bit review. Well, it's not really, it may not be a review. This might be new for some of you guys. Because again, I don't know if you're new to coding, then yeah, this might be super new to you. But we're going to talk about what is a programming language. So what is this? So when we talk about coding, right? When you hear people say this, oh yeah, I'm coding. What are they really doing? They're learning how to talk to the computer and give it a set of instructions that it can do, right, to complete a task. And we're talking about algorithms, right? So I know you've been using this word now for a lot of years, right? Because basically an algorithm is a list of steps that you can follow to finish a task. And that's what you're doing in a programming language, right? So I'm just going to share what they have here, but a programming language is a set of rules in which symbols represent actions. Programming languages follow step-by-step instructions that a computer executes in order for a project to run. VexCode VR is the programming language for a VR robot. So this particular program, they call their language VexCode VR. That's what they call their language. Like if you guys remember using Scratch, guess what? The language of the program Scratch, they call it Scratch. And it's blocks. It's the same, it's blocks. They just give it a name. And a lot of these programs are created just for students like you guys who are learning programming, you're learning coding, you're getting more comfortable with these things. And if you do decide to pursue this in high school or college, then you will move into the real programming languages. And these are the languages that you have to know to get in a career, right? To be able to work in this field, you have to really know these programming languages. So the blocks are for the beginners, to understand the concepts, to be able to just get a better idea of how the whole thing works, right? So again, if you're taking notes, hopefully you're jotting this down. So a programming language is a set of rules in which symbols represent actions, right? And they follow step-by-step instructions. So that's the basics about a programming language. So here's a little thing on this. This example in the Castle Crasher. When started, drive forward for 800 millimeters. So there you go. He's there saying how far to drive forward for. What is a behavior? So we think about a behavior. So it says behaviors are the actions performed or to be performed by a robot, right? So moving forward, stopping, turning, looking for an obstacle. These are all behaviors. And behaviors are defined by the programming language, right? So again, in these blocks, drive forward, that would be a behavior, right? We're telling the robot to drive forward. To change the behaviors of the VR robot, you can change the blocks in the program. These programming blocks are also called commands. So when you put together all of these blocks, we could say that you're putting together commands. And those are then allowing the robot to do a certain behavior, right? They're following the commands to do the behavior, which is what you want them to do. It's an action, right? So I'm trying to think how I could relate it with you guys. But you know, we talk about like real life algorithms, things we do in real life, right? So if we follow certain behaviors, then we will see a certain outcome, right? So we could make up an algorithm for anything, but if you're taking notes and you're taking them in the right order, then you will be successful on the quiz, right? So you wouldn't be able to just take the quiz without the notes. So so there's a step-by-step process, and it's the same thing when you're working with the coding. It's all about, okay, well, you're not going to just have the robot, you know, get to the, whatever it is, say you needed to get to the star or something in the game. You're not just going to say when started, go to the star. Well, how are you going to get there? You have to drive forward. You have to turn. How long do you have to drive forward for? They need behaviors. They need these commands to then achieve whatever it is that you're asking them to do. Hopefully that makes sense. So there we go. They're highlighting a red box here and they're telling you this is a command that you're having the robot do. So, gosh, I feel like I should probably just stop here. Let me show you guys the quiz. So everybody's going to get a link to this quiz. So what you have to do is you have to put your first name and your last name. And then there are 10 questions on the quiz. They are mostly multiple choice and true false. So again, if you took really good notes, then all of the 10 questions should be very easy for you. So you need to select one answer and then press the submit button when you're done. When you do that, you will be able, it will automatically score your quiz. You can see what grade you got on it. And that will be the grade that I'll put in for your score for this week. So this week is kind of like a review quiz of our introduction and our lesson 1. And I really would love to move on to the next part. But again, I feel like you guys just aren't ready for that because I didn't get enough of your files from the first week since we started. So what we're going to be doing in lesson 2 is learning how to drive forward and move forward and reverse. And this is going to help us with our little challenge that we're going to be doing. So I would love for us to get into the Castle Crasher challenge and get that done. But again, I need you guys to be cooperating and we have to work together on this, meaning that you have to do your part, right? So I'm preparing these lessons for you guys. And I'm really just going based off of how fast or slow you're moving. So if you guys move super slow and you don't really get stuff done, then we can only go that's the speed we can go for the rest of the year. And it'd be amazing if we could finish through this curriculum, you know, because it's a really great program. There's a lot of fun challenges, coding challenges, but you really need to be doing your part and getting these assignments done every week. So that way, then when you're done with them, we can keep moving on. Okay. So your assignment for this week will be number one. If you didn't finish the first assignment of sending a file to me, you need to do that. And then the second thing is to please take the quiz. So that will be your grade for this week. Take the quiz. And once everybody's done with that, then we will move on to our first challenge, the Castle Crasher Challenge. And hopefully we can do that next week. All right, guys. So I'm going to stop here, and then I'll be looking forward to getting all those emails with your first files, and I'll also be looking forward to your getting your quizzes, and then we'll see you guys next time. Alrighty, bye guys. Have a good week.